Hello and welcome to the Forward Together podcast. My guest today is Pierre Harter, Wichita State's interim associate vice president of research and industry engagement. Pierre has an extensive and impressive resume, including leadership roles at Spirit Aerosystems and Bombardier. And since 2020, he's been working to advance research at WSU's National Institute for Aviation Research. In his current role, he's focusing on growing and amplifying faculty-led academic research. Welcome to the Forward Together podcast, Pierre. Well, Pierre, it's good to see you today. Thank you for stopping by the podcast and talking about all things research at the university and your new role to help move forward a lot of things related to research, but faculty-led research, and talk a little bit about that. But first, before you went into the professional world, and you might want to talk about what you've done professionally, you're a shocker. You're earning both your bachelor's and master's degree here in aerospace engineering. We were just talking earlier that when you started working at the university in 1994 as a student, right? Yep. How did your education prepare you for your career so far, and what you've done in your career?
Yeah. So yes, a shocker. I actually started here fall 93, did aerospace engineering. And then in 94, I got a job in the composites lab. You know, back then, gosh, we were just talking 30 years ago. Back then you started, I started. We were about a dozen students working in the lab, and a couple staff members. And you look at today and wow, we're over 200 in just that lab alone. So for me, one of the biggest things, and I've taken this throughout my career and encouraged, and mentored many people to do the same thing. I think the experience that I got in the composites lab was equally as important as the knowledge I learned in the classroom, as far as how that helped me in my career. When I left here in 2000, I went to a small startup company out in Denver, Colorado. I was, with my background in composites that I learned in the lab and the structures that I learned in the classroom, I was our composite M&P expert, did a lot of testing, those type of things. And that really served me well throughout my career, where I had that practical hands-on knowledge coupled with the theoretical knowledge. And that took me to, executive leadership at Atom Aircraft, and then moved back to Kansas, worked for Bombardier Learjet, executive leadership in new product development. Then I went to Spirit Aerosystems, did a lot of R&D there, worked new product development, and then moved into advanced manufacturing. I think, working in that lab, and back then we didn't even call it applied learning at WSU, but really I am a product of that applied learning model. I think it also gave me a lifelong curiosity, lifelong learning. And so through the years, I've always taken the opportunity to pivot and learn new things. I got my MBA along the way, and then got into new areas like advanced manufacturing and digital transformation. And that's really what turned me on to coming back to the university back in 2020, is the opportunities here to kind of take us to new areas.
Yeah, the interesting thing I know about you, through all that, you never really lost sight of Wichita State and continued to collaborate and consult and, just figure out how to solve problems wherever you were. So that's what we do here at the university. I appreciate that. The next thing I want to talk about, the university's research has grown pretty significantly over the last 10 years. For years, we brought in about $50 million, and now this year we'll report bringing over $400 million, and our research expenditures will top $370 million. So that's phenomenal growth. And part of my goal is to move the university to an R1, R2, which we're currently now, which I want you to talk about what that means, to an R1. Not just to say that we're an R1, but I think there's some implications there that will help us maybe be at a different table, policymakers, with that designation. So talk a little bit more about that.
Sure. So let's start with, what that R1 and that R2 status means. So there's the foundation called the Carnegie Foundation, and they're really the leading framework for categorizing higher education in the U.S. And they bucket universities and colleges or post-secondary education institutions into several different categories. So we have R2, like you mentioned. So they're revamping their classification system starting next year. So I'll talk about what it's going to be going forward. So an R2 institution is a high research and doctorate production university. So that their new categorization system is you spend greater than $5 million a year
on research.
Yep, on research, and you put out 20 or more research-based doctorate degrees. Mm-hmm. To get to R1, the threshold's higher. It's going to be greater than $50 million of spending on research, which
we have that covered.
We've got that covered in spades. But the threshold for output of, the production of doctorates is 70. Mm-hmm. So if we look at where we've been historically over the last several years, we're right around 45 doctorates that qualify as research doctorates. Mm-hmm. We put out a lot more. Mm-hmm. School of Health Sciences, College of Health Sciences puts out quite a few. But right now for the research one, so that's the engineers, the chemists, the communication science disorder, the psychologists, those all count as research. We put out about 45. So we've got some ways to go to get there. We've already started working ideas. There's a classification system that all universities use called IPEDS. I know you know about that, but that gives us we have some say in the definition of what those are. So we've looked at areas like in our education, our doctorates in education leadership, we believe those qualify. So we think, that probably gets us 5 or 6 more right there a year. We're talking and looking in health sciences. There's potentially some there because we do have some research going on in the PT program and otherwise. So I think we're pretty close, or we can get there with a little redefinition. And then there's the potential of bringing in new programs like material science has been talked about, really a strong area for the university, and certainly with our strong background in testing and applied research around materials, that makes a lot of sense. So let's talk about why it matters, because I think that's an important question that many people maybe don't understand. I think there's several things there. You mentioned policymakers. Policymakers look at which universities are R1 versus R2. A lot of that leads to funding opportunities as we move towards R1 and we achieve R1. That really opens up the door to a lot more funding opportunities on both the basic side of the house, so a lot of the fundamental research that the academic side does, as well as on our applied research that we do. So more funding. Researchers look at that. So many times, especially very large research programs, the NIH type of programs, the NSF programs, they often are encouraged to do multiple institution research. And when you've, the primes, the universities that get those, they often look out for their peer institutions. So a lot of times we're not even looked at, even though we do have the capabilities, because we don't have that tag on us. So that opens up more opportunities for working with, nationally renowned, world-renowned researchers across the nation. And then, of course, there's the prestige that comes with it. And that's, some of that's nice to have, but I think there's the reputational side of that. As we become known as an R1 and all the things we can bring to the table, that just builds on things. So then you can recruit, you can recruit faculty easier. It brings more students here because of that prestige. So it all builds on itself. And that's really, I think, that, and that's why that's a goal for us.
Right. Yeah. And again, it's not just to say that we're R1. It's really to, ends to a means here. We want to be viewed as doing important work here on the research side. And when we are doing things differently, which I think is sometimes the traditionalist universities struggle with, seeing institutions like Wichita State move along this spectrum of R2 to R1. So that brings me to my next question. So what do we do differently in research, and what's driving that growth that we're experiencing right now in research?
Yeah, I think, really the hallmark for what we do differently is the focus on applied research. So you've got, your basic fundamental research. That's developing new science, new theories, doing stuff in the lab, test tube,
which we do,
right? We do,
yeah,
and we need to do more. But the applied side of thing is really, okay, now I take these concepts that have been developed, or I take solutions that have maybe been developed in one place, and I apply them to a different problem. And it's really about that. It's solving problems with technology. It can be solving new problems. It can be solving existing problems that haven't been solved in one industry, utilizing solutions that have been in other industries. So there's a wide variety of things. And that's really what we do special. When I first came back in 2020, I listened to yourself, I listened to Andy, I listened to John, explain to people. I mean, as well as I do, we have loads of universities coming here to figure out what the magic in the water is, right?
Right, yeah.
And so I listened to everybody explain what we do, and we came up with a slide that we show, and it's really the magic of our model. And it starts with, I think the first thing it starts with is us listening. Mm-hmm. So we're different in that we go into companies, to our government customers, and we listen to what their problems are. We don't come there telling them what we think a problem is that needs to be solved. It's their problem. Mm-hmm. So we listen. Then we go and solve that problem. And we do it at scale. We have very large labs. We know how to solve big problems. We do it at the speed of industry, which is also key. And maybe one of the most important things is the ability to bring in the students to help with that solution, the applied learning opportunities. I often tell people a lot of times the reason companies come to us initially is to solve the problem. A lot of times they keep coming back is because they see the power of that workforce, especially in today's job market and hiring market. One of the biggest reasons we're seeing a lot of the growth in the industry coming here and the federal, the ATF, people like that is because they want that workforce just as much as they want us to solve their problems. So when you do that right, and that's why I think it's a magical model, it's really a virtuous cycle. And we have, I explain it as a snowball effect. You solve a problem, they keep coming back, whether it's to solve bigger problems or for the workforce, and that just builds upon itself. And you can see how that's worked in multiple different cases in a bunch of different labs.
Really experiencing some significant growth in some of those areas. Like, you might want to talk about a few of them, like our digital twinning, some health science related kinds of research that we, like the molecular diagnostic lab. That was a good example of how.
That's a great one.
But anyway, I don't want to tell you what to say,
It's good. I'll start with the one that I know best because it's where I started as a student back in the 90s. So, back then we got kind of our first national scale program. It was called NASA's AGAT program, Advanced General Aviation Transport Experience. And NASA was really trying to insert new technology into general aviation to help it grow. And one of the areas was composite materials. And so they asked NIAR, Dr. Tomlin, and the composites lab to come up with a way to generate composite material allowables that can be shared across multiple companies. So that was developed. I worked on that as a student. That eventually turned into what is now the National Center for Advanced Materials Performance. So back then, there's 12 of us in the lab developing methodologies. That then turns into over 200 students and staff today working on things, making and breaking 1,200 material specimens a week for companies across the globe. And that's a really concrete example of how that's just snowballed.
Yeah, and that particular lab is a certified lab, right? The FAA and other, the European FAA utilizes that lab, and if it's tested and certified, whatever else you all do to it that satisfies their needs, the FAA's
Yep, they will accept that data for certification.
Yeah. Yep. And that really was one of John Tomlin's projects that he kind of stood up. That's where he kind of
PI on that.
Yeah, that's where he cut his teeth as a researcher. And he doesn't talk a lot about this, but it is amazing that Wichita State has that certification for these materials that are used in aircraft across the world, and it starts here.
Now that's another snowball effect. Now that's spun off into advanced manufacturing. So now we're doing that same thing that we've done for composites through the years. We're doing it now for additive manufacturing as well, and that's opening up a lot of opportunities for it.
Yeah, talk about the molecular diagnostic lab, because I think that's a good example of digital transformation coming together with health science folks, with robotics, other kinds of expertise that the National Institute for Aviation Research has to solve a big problem.
It is. So going back into COVID, of course, we're the nation's highest per capita percent of manufacturing jobs. that means that you can't build things when you're at home during COVID.
You can't build an airplane remotely.
You can't build an airplane. You can't build a skid steer. You can't build an air conditioning unit. All these different companies that build things here. So we had a big problem, right? When COVID first set out, you had to test. You had to go home. You had to wait for results. And Kansas did not have any facility in the state that could test. So things were being sent to Texas or being sent to Denver or to Missouri, and you'd sit and wait days, sometimes a week. And by the time you got the results, well, you've almost hit your 14 days. So, so that was a huge disruption. So I think, the governor came to you and John and said, you guys know how to test things. Go figure this out. And it's a great story. And I think it's a prelude to where we go from here and growth in the future. We've got all these wonderful abilities, sometimes in silos. But I think the key to unlocking our potential is bringing those abilities together to solve problems. So this is why this is a great example. So you had, experts from the College of Health Professions, Sarah Nickel. We had multiple different NIAR labs that deal with testing and with automation and digital type of work come together. And we partnered with a couple different institutes. We utilized some methodology that I think Yale University had developed for testing with saliva, which nobody said we could do it with saliva. And we figured out how to do this. And it was kind of that fresh thinking of people that haven't been in the medical testing world before that kind of unlocked the potential there. We said, hey, why can't we spit? Hey, why do we have to have all these custom test kits that can only be sourced in one place and have long lead time? Let's go buy off-the-shelf materials that we can acquire anywhere. Let's utilize those. Why do we have to have, a bunch of people doing a bunch of manual processes? Let's go automate this. So
there's a lot of doubters about this. Wichita State, would they be able to pull it off? And it was a concern for me too, because we're telling people that we are going to stand this lab up and we want it to be successful. So I was, wanted to make sure when we brought all those folks together that we were going to be successful. There wasn't really an option here. Right. And, one of the things I'll just add, and I'll let you continue on this story, is that don't tell Wichita State that they can't do something, because that just makes us work harder, and we'll do something. Yeah,
exactly. Yeah, we don't say no very often.
Yeah.
What's your problem? Let's go solve it. So and I was, while this was all happening, I was at Spirit and kind of doing my own journey there, where we were figuring out how to make ventilators for a company at the same time. So I was watching and cheering you guys on, because I needed to keep workforce building ventilators at the same time. But I think, the uniqueness there is, what ended up happening is we did find a way to automate it. We did find a way to use materials that were readily available in the middle of a pandemic. And we stood something up, I think, in like 2 months, including getting the FDA's CLIA approval of the lab. And now we have the capability of doing almost 20,000 a day. And I think, I don't remember the exact numbers, but I want to say that 99% of the results that, people turned it in the morning, it was done before the end of the day.
That was my experience. Yeah. And tested hundreds of thousands of specimens during that time, and still testing, because COVID has its, peaks and valleys, and we have had a little bit of increase of COVID in the environment, or a resurgence into the environment recently. So
developed multiple panel testing.
Yes. So that has led to us to develop other kinds of expertise in testing, that we're hoping that continues, and that's what we're planning anyway. So talk about one of these large-scale programs that that we have developed expertise in, that have really transformed a lot of what NIAR is doing, but other people at the university are working on in terms of digital transformation, but in particular digital twinning.
Right. Yeah. So digital twin, that started over 5 years ago, and it goes back even further. One of our core capabilities that we've had since you and I came to the university was training industry on how to use computer-aided design. So CATIA is the software that we've traditionally used. There's other software packages that we've learned through the years as well and teach now. So we've been experts in how to do computer-aided design. We've had a sustainment lab that's been experts in how to tear down an aircraft structure and inspect it and look for flaws and those type of things. We've had a full-scale structural test facility that knows how to test things. And so and a few other labs, but as we've grown larger, we've gone beyond just a company or a government agency coming to us for one lab. They're coming to us for a capability. So digital twin is really about bringing those multiple labs together to provide a capability and a solution. So digital twin started with F-18, but now we've done B-1B bombers, we've done Black Hawk and Apache helicopters, we've got F-16, we've got ground vehicles now, M113 armored personnel carrier, and multiple others. And that's grown, to our largest award yet to date is $100 million from B1 to take it beyond just, take a part of B1 and convert all the 2D data into 3D data. But it's gone beyond that now into, provide me additional solutions that use that structural digital twin that we built and expand on that in many different ways in a digital twin perspective. And now we're, with the National Institute for Research and Digital Transformation, and working closely with NIAR, we're developing other digital twin type of capabilities. So think digital twin of a factory floor. We do a lot of scanning and produce digital twins of the actual structure and the facility, but now we're trying to put the smarts into that. So can I take all the data coming off the machinery and see that in a digital twin and use that to predict things like maintenance? I need to fix a motor because I see it vibrating in the digital twin.
Yeah. So about these digital twins, so that facility that you're talking about, where a large part of that work is done, is in the former Coliseum, the Kansas Coliseum, up north of us in Park City, which we've acquired all of that that facility and the whole complex, and did a number of things there. But this digital twinning program, for the most part, really is to help sustain the military aircraft long term. I don't know if a lot of people know this, but I think there's like 45 B-1B bombers still flying.
Yep.
The company that manufactured that plane, which one was that?
Doesn't even exist anymore.
Yeah. Okay. That's what I thought.
And through acquisitions, it's now Boeing.
Yeah.
Inherited it.
Yeah. So they're not making parts for that plane, and so one of the initial reasons, my understanding, is to do that digital twin is to help them with that problem of one-off parts through additive processes or whatever. So that is a major solution for the military's readiness. And those planes, I believe they want them to fly for another 30 plus years. So it's just not...
Probably at least.
Yeah. It's really expensive to develop new bombers, and military is doing that, but that takes a long time, a lot of resources to do that. And the B-52 is another one.
We just started the digital twin of that, yeah.
Yeah, and that's all the B-52s are built here in Wichita, and now the military is still flying those.
They're putting new engines on them, so those things are going to fly well beyond. They're going to be over 100 years old.
Yeah,
still flying.
And the reason why they can is because of the sustainment work that we're doing through this digital twinning process. Yeah, so really interesting. And if anybody ever has an opportunity to go see that facility, you will be blown away of what they're doing. They're taking apart piece by piece these very large aircraft and digitizing them and then putting them back together in a digital file.
Tens of thousands of parts.
Yeah, yeah. So
it's a lot.
Pretty incredible. So
it's a jaw dropper.
Yeah, those are all really good examples of how we, as you said before, listened to what the issue was and then brought our resources together to help solve that problem. And that is why our research is growing. If you look at the research growth the last 10 years across the country, all universities, it's about a 5% growth. I mean, ours has grown 30%. And that is an outlier. And the reason why it is because of this work that we're doing. And then really the most exciting thing is that many undergraduate student opportunities and applied research, applied learning opportunities with those programs. So how many people work at NIAR? Student workers, but close to 1,000, right?
We're close to 2,000 total staff and students, and roughly, like you said, about half of those are students at any given time.
And, I'm out and about all the time talking to students, and every other one of them is working at NIAR. And, not all engineering students either. There's other majors of students working in alongside those.
Every college represented at NIAR, for sure.
Yeah. So, talked a little bit about what kind of research we do and how we do it and how we go through that process. And by the way, listeners, we're not trying to be a traditional research university. We're trying to be who we are and who we serve. I think that's sometimes challenging for people to get their heads wrapped around that. But what do you see as the future for research at Wichita State?
Yeah, I think let's start by grounding ourselves, and we've talked about it during the conversation here, but I think it's important to highlight the points. When we look back from where we've come, even just from as recently as 2020 to now, over 240% growth in research expenditures just in that 4-year period. So, like you mentioned before, we're going to break $400 million this year. So that's kind of where we are, and we've done that as we talked about here. We've done that by harnessing our strengths and building upon those and investing in the right areas and listening to our customers and building things to solve their problems. So when I think about the future, I look to your vision, right? The 3 main points I always highlight to folks are: we want to be the premier urban public research university in Kansas and let's say nationwide.
We're the only one in Kansas,
yeah.
So I think we got that box checked.
Yeah, we do. Fair enough. We want to have that applied learning. We think that's important, and we see that every day from when we listen and talk to our industry and government partners. They need that. They want that workforce. It's valuable to them. That practical experience that they're getting from the classroom and the applied learning experiences, and then drive economic prosperity, right? So from those 3 things, where I see us going is forward with a mix of building our basic research capabilities. That's mostly the academic side of the house. So going about helping, grow that, helping our faculty with learning how to write grants, pairing them up with the right partners that provide that funding. Part of getting to that R1 is building that prestige that makes it that much easier for them to get that funding. But then coupling that with growth in the applied learning area. And I've got some examples. Of course, our next big thing is the biomedical campus downtown. I watch the live feed every morning just to see where we're at.
Yeah.
And that's a great example of growth, and that's partnering with KU Med and using the strengths of Wichita together, right, to do that. And one of the things we're doing on the research side to harness that synergy that we have with biomedical campus is what we call the Institute for Rehabilitative Medicine and Assistive Therapy. So IRMAT is the title. We haven't gone public with this. We're actually getting ready to make a press release, but it's really neat, and I really like it because, again, it's taking multiple things that we have that aren't necessarily working together today and bringing those together to provide something that's greater than the sum of the parts. So we've got a really good clinical base, patient base, and clinicians in the College of Health Sciences that know what the problems are, have the patients that we're able to understand problems and bring solutions to. We've got a really strong biomedical engineering department that understands the science of and solving those problems. And then you couple that with what we have in industry and defense programs between NIAR and NERT in the ability to create prototypes, make proof of concepts, come up with, let's say, 200 prototypes that can support a clinical trial. And if you bring all that together, Dr. Dean Hand and I have looked long and far, and we haven't seen anybody that can do that all together in one place. So it's pretty unique. We think that can make us stand out. And so that's an example of really taking our strengths and looking some areas that we're almost to the, we're right at the precipice. So let's do a little investment and nudge, and that'll take us into the prime time. So IRMAT's a really great example there. Another area that we talked about it before is really, we've taken that composite expertise that we've had and moved it into additive manufacturing, and we've got robotics and automation. And so all that's leading into advanced manufacturing. We've got the new hub for advanced manufacturing and research going up. The steel's going up right now. That's another area that we're pivoting outside of aviation, but using those strengths and capabilities and going into other industry sectors to do that. And then maybe the last example I'll give you is, around data analytics and AI and machine learning. So a few years ago, we've had multiple colleges now bring new degrees to the table to deal with data and analytics. And we're also, from a research perspective, we're also putting a lot of emphasis there as well. So I'm working with, all the different folks around campus that have to deal with high performance computing on the academic side. And we're putting together a strategy for where we need to be in the next 2 years, 4 years, 6 years, 10 years, where the investment needs to come from, where the focus needs to come from, where the opportunities are. Another area Dean and I are working on is the Kansas Center for the Advancement of Healthcare. So that's really working with all the different entities within our state, whether it's state associations or insurance companies or hospitals or providers. All of them have disparate databases. Let's bring that all together so to facilitate research across entire populations or regions or cities or different types of disease types, where you can see that kind of from cradle to grave data across the population. And then maybe the last area is around AI. Keep your eye on the news in this area. There's an amazing amount of advancement. There's some people call it a wave, and it's moving very quickly. And there's a lot of concerns about, as these models that are out there start to approach and eventually take over the capability of human intelligence, there's a lot of things we need to do to make sure that they don't do bad things, or they aren't put in the hands of a bad actor. The power of creating, new biological weapons or launching having the nuclear codes and launching. So there's a lot of work around AI security, and that's another area where we think we've got the abilities of testing and evaluating and doing things for our government, and we can broaden that into the AI and the ML field.
Yeah, it's amazing work. You mentioned some people on the way. I just want to make sure people understand that we don't do this work just on our own. It takes a lot of collaborators. So John Tomlin, who's our Executive Vice President for Research and Industry Defense Program and the Executive Director of NIAR, been here for a long time. Andy Schlapp, who's VP for Government Relations and Strategy, who really works on trying to get policymakers understanding what we're doing and helping direct resources to the university. And then Dean Greg Hand, who's our Dean of the College of Health Professions, who really has moved the data science piece of it and on the health side, and also the rehabilitative medicine side, in concert with the biomedical campus. So, and a little bit about that too. I want the listeners to understand is that we developed the Innovation Campus about 10 years ago. Actually, yeah, it's 10-year anniversary this year. But a lot of what's on the Innovation Campus was built 8-9 years ago. And we learned from that. If you put infrastructure there, we had the NIAR labs. We developed the John Bartas Center, the experiential engineering building. New crash lab, just opened the home to NIRT, National Institute for Research and Digital Transformation, which is called
Digital Research and Transformation Hub.
Right, I always forget that one. And then now we're building Hammer, the Hub for Advanced Manufacturing Research. And so this is all infrastructure, laboratory space, and one of the reasons why companies have moved to the Innovation Campus is because they see that, and the utilization of that helps them move their industry segment forward. The same thing with the biomedical campus, putting that infrastructure in place, moving our health science and WSU Tech health science assets and KU Medical School, along with their school of pharmacy, down there with an already existing DO school or culinary school. The city gave us that land, obviously, to help make that happen. But the county is also investing down there in mental health. They're moving the comm care there. And HeartSpring just announced, which is a neurodevelopmental organization that helps mostly children working with neurodevelopmental issues. They're going to move their pediatric outpatient services down there. So just now starting the construction of the biomedical campus, but before we even have steel coming out of the ground, we already have a lot of investment in this ecosystem around health sciences, just like this ecosystem that we've created on the Innovation Campus. Starting with aviation, but it's branched into many other areas, as you said. I think that's a major misconception by people in the state. They think all of our research is aviation research. Well, big chunk of it is, but we're really branching out into these other areas because of that expertise that we have developed over time in aviation.
It's really exciting. And one of the things that really excites me, it's not just people moving from one part of the city onto the Innovation Campus. It's people that, companies that have never been here before in Wichita or even in Kansas coming here. We've seen many instances, and that's bringing new research opportunities. That's bringing new job opportunities. So it's it's a virtuous cycle.
Yeah, I fully expect that with the biomedical campus. Well, Pierre, it's good to see you and sit down and talk with you.
Thanks for the opportunity.
You're welcome, and good luck to you. I have to bring it back after you get more involved with the faculty and helping them move some of their projects forward.
For sure.
And so we appreciate
that. Would love
to.
Okay,
thanks.
Thank you.
And thank you all for listening. And be sure to rate, review, and subscribe wherever you listen to the Forward Together podcast. Go Shockers!
Sponsorship for the Forward Together podcast is provided by Scott Rice Office Works and the Shocker Store. Additional thanks to NIAR AMP, WSU Carpentry Shop, and Go Create.